In 1964, a Zambian science teacher announced he was going to beat both the United States and the Soviet Union to Mars. His crew, a 16-year-old girl, 2 cats, and a missionary. His rocket, a catapult, his training program, rolling his astronauts down a hill in an oil barrel. He was not joking. Here's what's wild. That Zambian schoolteacher, laughed off by the entire world, understood something that the greatest superpowers took another 60 years to fully grasp. Space is not a destination, it's a resource. And right now, a new space race has ignited. One that makes the Cold War rivalry between America and the USSR look like a neighborhood argument. This one involves nations, billionaires, and a moon full of something that could end the global energy crisis forever. Let's start with the moon. The moon's surface is covered in a layer of dust and shattered rock called regolith, and buried inside it is an element almost entirely absent from Earth, helium-3. For billions of years, the solar wind has been bombarding the lunar surface and depositing it there. Earth's magnetic field deflects most of this. The moon has no magnetic field, so it absorbed it all. Why does that matter? Because helium-3 is theoretically the ideal fuel for nuclear fusion, the same process that powers the sun. Fusing it produces almost no radioactive waste, no contamination, and an almost incomprehensible amount of clean energy. Scientists estimate there are roughly 1 million tons of it sitting in the lunar soil right now. As little as 25 tons could power the entire United States for a year. But helium-3 isn't the only thing up there. The moon is also rich in rare earth metals, neodymium, dysprosium, lanthanum, elements that are essential for every smartphone, every laptop, every electric vehicle battery on the planet. And right now, China controls roughly 60% of global rare earth production and over 85% of the world's processing capacity. That's not a supply chain quirk. That's a geopolitical lever. Mining the moon cleanly without destroying another ecosystem could change that balance entirely, which is why NASA built the biggest rocket in history to go back. The Artemis program is America's most ambitious undertaking since Apollo. And unlike Apollo, which was a geopolitical sprint, Artemis is designed as a permanent return. The target is the lunar South Pole, where permanently shadowed craters are believed to hold vast deposits of water ice. Water that can be split into hydrogen and oxygen, rocket fuel. A gas station 240,000 miles from Earth and orbiting above the surface will be the Lunar Gateway, an international space station in lunar orbit, serving as a staging point for surface missions, a research hub studying deep space radiation, and a testing ground for the life support systems that will keep a crew alive on the multi-year journey to Mars. The Gateway isn't just a moon project, it's the first brick in the road to the rest of the solar system. But here's the twist nobody predicted 20 years ago. The most consequential players in this new space age aren't governments. For most of the 20th century, going to space required the industrial might of a superpower. Then the price of getting to orbit started to collapse, and 3 private companies changed everything. Richard Branson's Virgin Galactic takes the most cinematic approach. A massive carrier aircraft releases a sleek space plane mid-flight, which ignites its engine and arcs up to the edge of space. Enough for a few minutes of weightlessness and a view of the Earth's curvature. Branson's vision is space tourism, not orbit, not the moon, just the experience of being briefly above it all. Jeff Bezos and Blue Origin think bigger. His New Shepard rocket goes up, touches the boundary of space, and lands again. But Bezos's stated philosophy goes further. He wants to move heavy industry off Earth entirely, manufacturing the polluting things in the clean vacuum of space and preserving our planet as a kind of garden world. And then there's Elon Musk, the one who actually changed the math. SpaceX's Falcon 9 does something that sounds simple, but is genuinely revolutionary. After delivering its payload, the booster flies itself back to Earth and lands, upright, on its legs, ready to fly again. Before SpaceX, launching 1 kilogram of cargo to orbit cost around $54,000. SpaceX brought that number down to roughly $2,700, a 95% price collapse in under a decade. And in 2020, while Bezos and Branson were chasing the tourism market, Musk launched American astronauts from American soil for the first time since 2011. For 9 years, NASA had been paying Russia $86 million per seat on the Soyuz rocket just to reach the International Space Station. That dependence is now over. But SpaceX's real ambition is Starship, the largest rocket ever conceived, designed to carry 100 people on the multi-month journey to Mars. Musk isn't interested in tourism. He wants to make humanity a multi-planet species, and he believes, sincerely, it is the only way to guarantee our long-term survival. Someone else agrees, and they've been building toward it quietly and methodically longer than most people realize. China's space program doesn't get the social media coverage of SpaceX. There's no live stream, no eccentric billionaire, but what they're building may be the most coherent long-term space strategy in history. The Tiangong space station, completed in 2022, has a singular focus that the International Space Station doesn't: deep space self-sufficiency. Every major experiment on board is oriented toward that goal. Said Chinese taikonauts are researching orbital 3D printing, manufacturing replacement parts and structural components in space, eliminating the need to launch everything from Earth. They're developing robotics capable of constructing habitats on the Moon or Mars autonomously before humans even arrive. They're testing artificial photosynthesis, a closed-loop system that converts CO2 and water into oxygen and rocket fuel using sunlight, potentially keeping a crew alive indefinitely without resupply. The end vision isn't just a moon base, it's a network, a solar system-wide infrastructure of manufacturing hubs, research outposts, and resource facilities. Some Chinese officials have called it a cosmic Silk Road. It's an extraordinary ambition, and the fact that it comes from a state with the resources, the patience, and the long-term planning horizon of China makes it credible in a way that no private company's roadmap quite is. So that's the landscape. America and its allies racing back to the moon. Billionaires dismantling the cost of access to orbit. China building the scaffolding for a multi-planet civilization. A species-level question hanging in the air. Who gets there first, and what rules do they set when they arrive? Which brings us somehow back to the man with the oil barrel. It's 1964. Zambia has just gained independence from Britain, literally weeks ago. The entire country is trying to figure out what it is. And in the middle of all that, a science teacher named Edward Makuka Nkoloso announces to the world that Zambia is going to Mars. His 12 trainees, he called them Afronauts, included a teenage girl named Martha Mwamba, already 2 cats, and a missionary whose job was presumably to handle the spiritual dimensions of interplanetary travel. Training involved rolling down a hill in oil drums to simulate turbulence and being swung on a rope to simulate weightlessness. He approached UNESCO for funding. They declined. The world treated Nkoloso as a joke. European and American reporters flew in to write mockery disguised as curiosity. His space academy, which operated out of a farm, became an international punchline. But here's what those reporters missed. Nkoloso was deeply aware of the absurdity. Many historians now believe the entire enterprise was partly political satire, a pointed challenge to the colonial powers who had spent decades telling Africans what they were and weren't allowed to aspire to. By announcing a Zambian mission to Mars, he was making a statement: we dream as big as anyone. Mata Mwamba got pregnant and left the program. The cats escaped. The catapult was never built. The program quietly disappeared. Nkoloso died in 1989, having never seen a single Zambian reach space. But in 2024, Zambia launched its first real satellite. It orbits Earth right now. 60 years after he rolled teenagers down a hill in oil barrels, the country he was trying to put on the map is in space. He was not wrong. He was just early. We are living in the most consequential period in the history of human spaceflight, and most people are barely paying attention. The moon is sitting there, 240,000 miles away, full of the fuel that could end the energy crisis, the metals that power our civilization, and the water that could launch us to the rest of the solar system. So the stakes over who controls these resources, who sets the rules, who arrives first, couldn't be higher. And woven through all of it is the same impulse that drove a Zambian schoolteacher to stand in front of an oil barrel and tell the world his people were going to the stars. We cannot help ourselves. We have to go. If you made it this far, thank you. If this video taught you something, hit subscribe. We cover exactly this kind of story every day: science, history, geopolitics, and the mysteries that don't make the front page. And I want to know what you think. Should space resources be treated as a global commons belonging to all of humanity? Or does whoever gets there first have the right to claim them? That debate is very much alive right now. Drop your answer in the comments. I read every single one. Watch the video on the right next. I'll see you there.